Good day, friends. I welcome you again into BrainPoint Academy. You are welcome. So in this segment, I'm going to release very important video this morning. I want you to pay attention, get yourself prepared. We are in charge, okay? So in this segment, we shall be looking at the causes of motion. Because in our previous class, we discussed motion. I told you the meaning of motion, types of motion, and application of each type. So in this segment, we are going to look at the part B aspect of it. And that part B aspect of it is causes of motion. So we're going to look at what actually gives rise to motion. Please pay attention. Okay? So after the end of this class, please, I want you to subscribe to this channel. So reason for subscription is for you to be getting the current updates on my teachings. Anytime I release a video, you get notification. Are you with me? So subscribe after the end of watching it, after you finish watching it, okay? Also like and also share it on the various platforms where your friends can be possibly located. Very important, okay? Good. Now, back to the cause of the topic this morning. This is causes of motion. So please pay attention. So what causes motion? What do you think that gives rise to motion? Okay? Now, in our previous class, we discovered that motion is the change in position of an object with time. Okay. Now, that change in position of an object with time does not brought itself. An object cannot just start changing its position without a cause. There is an agent, there is a factor that gives rise to motion. Are you with me? Good. And that thing that gives rise to motion is what we call force. I hope all is well. Good. Now, to recall your mind on what Isaac Newton said in his first postulation of law, he said that an object will continue to stay at rest or uniform motion on a straight line unless if acted upon by unbalanced force. So now to break down this law, okay, so what does it mean in a real man in reality? What it means is this, that in absence of force, you find out that an object will continue to remain the way it is. Are you with me? You under the sound of my voice, before you begin to change position, before you begin to change from your initial position to the next place, you might have been acted upon by unbalanced force. Are you with me? So, if an object is not acted upon by unbalanced force, you find out that the object will remain the way it is. Okay? Are you with me? So, which means that force, or before an object begin to make a movement, begin to make a motion, there must be what causes it. I hope all is well. And that thing that causes motion is what we call force. Now let us now look at force in detail. What is force? Now the definition of force is this. Force can be defined as the agent that causes a body to move or to stop. It is incomplete if you say that force is an agent that causes a body to move only. Are you with me? It is an incomplete statement. But it is a complement when you say that force is an agent that causes a body to move or to stop. Because what causes an object to move must be the same thing that will cause the object to stop. That is a complete definition according to physicists. Okay. Now, that force in question is measured in Newton. Are you with me? Force is measured in Newton. Are you with me now? So the SI unit of force, the drive unit of force is Newton. Are you with me? Good. Now, Isaac Newton released three important laws, which is Isaac Newton's first law, Isaac Newton's second law. Now, in Isaac Newton's second law, precisely, he said that force is equals to ma. Are you with me? That is the summary, because the summary of Isaac Newton's second law is that Isaac Newton's second law was able to tell us the magnitude. That is the size of that force that must be present before the object begin to make movement. Are you with me? So that size of force has been approximated as this. That force is equals to mass times acceleration. Okay? From here, you can also drive a unit that is equivalent to Newton. Let us go together. Now we know that m, being the mass, is in kilogram. Are you there? Times. Acceleration is in meter per second square. This is meter per second square. Now, generally, force is now kilogram meter per second square. Then I want to speak to you in advance that Newton, we have already said that force is measured in Newton, right? Force is also measured in kilogram meter per second square. I hope all is well. Now for exam references, you can be asked which of the following units is equivalent to Newton. Which of the following units is equivalent to Newton? They can write option A, kilogram meter per second square, B, kilogram meter per second, C, Newton per meter square, D, Newton per meter. Are you with me? So they can be asked which of the following units is equivalent to Newton. Please, just kindly go straight to kilogram meter per second, because from what we have proved here, 1 Newton is equivalent to 1 kilogram meter per second square. So this is what is equivalent to Newton. So I hope all is well. So please take note. Now, to further our teachings, that force is a vector quantity. Force is also a vector quantity. Okay? Why is it so? It is a vector quantity because it has magnitude and also direction. It has both magnitude and what? Direction. So force is one of the vector quantities. I hope all is well. Good. Now, force has dimension. Okay? Dimension of force is mLt square. mLt square. That is the dimension of force. mLt raised to power minus 2. Okay? Good. This is for dimension of force. Okay? So force is dimensionally given as this. I hope we are still moving together. Alright. Good. Now, these are the peculiar properties and detailed explanation of force. Now, let us now look at the types of force. Okay? Good. Now, pay attention, because in this year exam, whichever exam you apply into, you are going to smash. Alright. We're going to look at types of force. Types of force. Types of force. Now, how many types of force do you know? I believe you may not know it. Some of you know. So we have 2 types of force, basically. So force is grouped into 2 categories. Number 1 is contact force. Contact what? Force. Contact force. Let us discuss this one before we look at the second type of force. Now, what is the meaning of contact force? Just as the name implies, a contact force is a force that requires the joining surfaces of 2 objects. Are you with me? So a force that brings a relative motion between 2 objects in contact is said to be a contact force. Are you with me? So what are the examples of a contact force? Example of a contact force include, we have pulling. Are you with me? Pushing. That is pulling force, pushing force, tension. Are you with me? Also friction. These are the examples of a contact force. Before such forces exert their effects, 2 objects must be present. Are you with me? Take for instance, friction is one of the contact forces. Friction is a force that acts between 2 objects in contact. It brings a relative motion when an object are closer to each other. I hope all is well. So, I believe that you have understood a contact force. Now, to go further, we have another type of force we call non-contact. Non-contact force. Non-contact force, or in other words, you can call it field force. Field force. If you don't call it non-contact force, you can as well call it field force. What is the meaning of field force or non-contact? Non-contact force is just a reverse word to contact force. It means a force that doesn't require the joining surfaces of 2 objects. Are you with me? So, in non-contact force, the 2 objects in questions must not be closer to each other before an effect can be created. Are you with me? So, a non-contact force are forces that exert their effects when 2 objects are placed apart. Take for instance, examples of non-contact force include magnetic force. Magnetic force is one of the examples of non-contact forces. Are you with me? Why is this so? Take for instance, you place a bar magnet in this form. You know, a bar magnet has two poles. We have as North Pole and South Pole, okay? Or you can say we have a South Pole and North Pole. Let's assume that we have a nail or an iron substance placed. The iron and the bar magnet, this is bar magnet. The iron and the bar magnet are not close to each other. Are you with me? So the two are not close. There is a separation between the two. There is a separation between the two substances. Are you with me? There is a distance apart between them. Now, this magnet, for the fact that the magnet and the iron are not close to each other, but this bar magnet has some forces. There is a force that emerging from this magnet that will even make this iron here to begin to change its position. Are you with me? So when you subject an iron in front of a bar magnet, what's happening is that the iron will begin to deflect. They begin to shake like this. So the shaking sensation of the iron is because the iron has been subjected by a non-contact force. So in non-contact force, the more non-contact forces to have an effect, the objects they are to change their position must not be in a close contact with them. Are you with me? So that is what we call non-contact forces. Non-contact forces act over a distance. So magnet will influence an object that is placed apart to begin to change its position, even when the object is not in close contact with the bar magnet. The same thing likewise to gravitational force. Before gravity begin to affect you, are you with me? Before gravity begin to affect you, okay, it must not be closer to you. Take for instance, we are made to understand that gravity has a constant value on a space, okay? So gravity says that whatever goes up must surely come down. Why are you coming down? If you throw an object upwards, before you know what's happening, the object will begin to reach a maximum height on a space before it begins to come down. Why is it coming down? It means there is a force on a space that is trying to retard the motion of the object you thrown upwards. So that's constant, that force that is bringing the object down to the earth. You are not seeing it. Are you with me? But we are just made to understand there is a force, there is an invisible force on a space. Are you with me? So gravity is one of the non-contact forces that makes an object to come down to the earth. I hope all is well. So now further examples of non-contact forces include electrical force. Are you with me? So in case of exam references, if you are asked which of the following is the non-contact forces, if you see magnetic forces, go with it. If you see electric force, you can as well pick it. If you see gravitational force, is also good. Is also one of the 8 examples. I hope you understand something from this video. Very interesting. So please, if you actually understand something very unique, I want you to subscribe to the channel. Don't forget to subscribe. Don't forget to subscribe, like the channel, and also share this channel to your various platforms where your friends can be possibly located. I hope all is well. Good. And also please drop your comments on the comment section. Your comments should also include the area where you don't comprehend very well on the course of my teaching. Anywhere you don't understand, you are free to drop your question on the comment section. I will react to your questions immediately. Are you with me? So I'm going to release another teaching, another topic after this tomorrow. So please get yourself prepared. Okay, turn on your notification button so that you get a current update on my tomorrow video. Very important. So thank you and God bless you.